you doing?
I'm checking my feed on Afari. The content creators on here are great.
I'm sure they are, but we're a little busy right now.
Oh yeah, sorry. Okay, so next up we have Alira Infrared Biosensing, who's creating a laser that uses, that becomes a sensor that non-invasively detects biomarkers.
Let's take a moment to think about what matters most in our world. Our bodies, our air, our food. Throughout our history, we have been striving to engineer ways to make these better. But the first step in being able to engineer is to understand. And to understand, we must first observe. At Alira, we are developing a tool to do just this. Our sensor, which has been developed at Princeton University over the past decade, will give doctors, scientists, and everyday people a new eye in which to observe the world, enabling them to better our health, clean our air, and protect our food and drinks from contaminants, and maybe make things a bit tastier in the process. We can do this with MIRI, our mid-infrared eye.
Hello, I'm Alex Worth, the CEO and co-founder of Alira Infrared Biosensing. I hope that our video gave you a sense of how observing the world, and observing the world specifically using light, can really create a lot of progress. And the idea of using light for sensing is nothing new. It was actually in the 1850s that scientists like Leon Foucault first discovered that you could differentiate different materials by the amount of light that they absorbed. And since then, the field of spectroscopy and optics has vastly grown. We now use lasers to look for water on Mars, to detect gravitational waves, and do high precision surgeries in hospitals. At Alira, we're taking this a step further by bringing these high precision spectrometers out of the lab and into your hands. We do this with MIRI, our mid-infrared eye. So what we have here is a mid-infrared quantum cascade laser that is very high power. The light being sent interacts with molecules, and then we have a high throughput collection mechanism which collects this information and funnels it to intelligent machine learning algorithms which can predict the molecular concentrations. What this provides is continuous and non-contact sensing. You don't need to interact with the material that you're looking at. It provides selective and sensitive measurements of a wide variety of molecules, as well as being user-friendly and robust. With a single click, you're able to get all the information you want from your material, and it's handheld and portable. You can bring it right onto the production floor. But probably most importantly, our platform technology is extremely versatile, which means that it can be applied to a wide range of markets and applications. The first industry that we're looking to enter is the wine industry. Now, this might seem odd to some of you because of how the wine industry has historically relied on the refined senses of veteran winemakers to make high-quality wines. But actually, throughout the past century, the wine industry has become very technologically and scientifically advanced. But one thing that they're still missing is a fast, convenient, and accurate sensor to measure the molecular content of wine. We can do that with MIRI. And not only that, we can completely streamline the entire process from grape to glass. Currently, winemakers use things like wet chemistry or bulky desktop tabletop spectrometers. Wet chemistry tends to be very tedious, and some of the experiments and tests can take days to get results back. The other spectrometers that are out there on the market tend to have contamination issues and therefore lack in the accuracy. Our sensor can do all of this and more. Plus, its portability, again, will allow us to bring it in every step of the process from grape to glass. When winemakers first bring the grapes into the system, we're going to be able to measure the molecular content of the grape juice. The grape juice is then moved to fermentation tanks. This is a very critical process, and we're going to be able to do frequent measuring with MIRI throughout the entire step of the way. The wine is then moved to aging barrels, and with MIRI, we're going to be able to look inside every single barrel. And last but not least, the wine bottling production line. We're going to be able to bring MIRI into the production line and look at every single bottle. Now, just to really drive this message home and paint a picture of how this specifically will help winemakers, is the example of acetic acid. Now, acetic acid is a very small molecule that can cause big problems for winemakers. And the winemakers that we've spoken to have expressed that if you catch acetic acid starting to form in your wine, acetic acid turns high-quality wines into vinegar, which is highly undesirable. If you catch it early, it's a very simple thing to fix. But if you let it skyrocket out of control, this problem will cost tens of thousands of dollars. So having a convenient portable system that allows for more frequent measuring will allow you to stop this before it becomes a problem. In result, we're going to save winemakers time, money, and improve the quality of their wines. Now, we take this a step further too, by having a multifaceted business model that will ensure initial revenue and value creation. So we do this by first providing a mobile service. So again, our system is so robust, we can put it on the back of a truck. We're going to have a mobile service where we provide sensing and diagnostics for winemakers who don't currently have the infrastructure to do this sort of sensing themselves. Subsequently, we're going to be able to retrofit the current infrastructure of wineries in order to have a single sensor which can now measure all of their tanks and barrels. Lastly, for large winemakers who want to do continuous monitoring, we can build custom systems to meet their very needs. Now, I just want to remind you, the wine market is just one small piece where we're first entering. But we have a very versatile sensor and an adaptable business plan, which will allow us to expand into many different markets, including first entering other liquors, food, and eventually entering into the healthcare industry, which spends billions of dollars every year on these kinds of sensing and diagnostics. Now, this might sound like a big challenge, but we have a star team to do it. We are a team of Princeton scientists and entrepreneurs who specialize in things like spectroscopy, laser and detector fabrication, as well as machine learning algorithms, the backbone of our technology. And we have gotten proven traction. So far, we've been giving grants by both Princeton and the New Jersey Health Foundation, totaling $150,000, as well over the past year, winning a series of pitch competitions with winnings totaling over $30,000. So what we need now is for you to join us. Join us as part of our group of beta customers to help accelerate this production process, as well as to join us to bring high precision spectroscopy out of the labs and into your hands. Thank you.
Thank you, Alira. And now for Q&A.
So great job. So this was incredibly interesting, and I would love for you to go a little bit more into why you chose wine as the first use case. So I'm in the healthcare industry, and I really understand how that would fit there. And I'm just curious if you've actually worked out the economics of doing a pilot in a winery, and if you know that they'll actually pay for this.
Yeah, so we've gone out and, well, to answer your first question, why we chose wine. We were approached by people in the industry who said, this will be really good for what we need. And it turns out the wine industry, compared to other food markets, et cetera, have less, and of course healthcare as well, have a lot less regulation. And they have a lot of interest in this sort of technological and scientific equipment. They're sort of science nerds like us. So we can relate in that way. In terms of the economics, it's again, a smaller market, but definitely something that a lot of people are excited about, and we've given them, so our system is we've priced it similar to the sort of commercial wine testing spectrometers that are on the market, which is about $100,000. And they've sold, to many wineries across the world, and we see that as a very competitive market for us as well.
Yeah, nice presentation. I think, though, maybe a piece of feedback, it took you a long time to get to the problem. And so I might want to encourage you in future presentations to, that 10,000, that was a nice number. I mean, the acetic acid problem seems like a real problem.
It is, yeah.
It took you a long time so you hooked me then.
Yeah.
So just a suggestion about, start with the problem, start with the market. When you talk about versatile to investors, they're not really into that because they want to know what specific problem are you solving and who's the person who's going to pay that to solve that problem. Right. So just a piece of advice, but it's hard with sort of a sophisticated technology to get to that point. So good job.
Yeah, thank you.
I really appreciated the kind of the history lesson and the reasoning behind this.
Yeah.
I also really appreciated that it seems like, again, to the initial comments, like this could be used in a number of use cases, and I appreciate that you have focused in on a particular segment.
Yeah.
My one follow-up question is, you mentioned that a part of this is actually feeding this into a machine learning system. What part does that play as opposed, I would have expected it's just like, okay, here are the numbers, they're in the right range or not in the right range.
Yeah.
What does the ML part do?
Yeah, so this is actually one of the biggest distinguishers of our technology. So the first is that we have a mid-infrared laser, which is a fairly new technology. And the second is combining that with the machine learning algorithms. So what this allows us to do is look at and understand the molecular content of materials that people previously never thought it was possible to do. And those are very complex materials with a lot of very long chain polymers, et cetera, and they just want to know sort of the information about these more simple molecules. If you use another light range or if you don't use the machine learning algorithms, your technology is not going to be as adaptable. With the wine market as an example, each type of wine actually has a pretty different structure, or the location it is, or et cetera. So building a system that can do everything with one system is quite challenging. But with the improvements in machine learning algorithms, we're going to be able to do that.
And can you, if you train it upon with one winery, can you apply those to another winery, and that's all cool?
Exactly.
All right.
Yeah.
It's a really interesting innovation here. I'd like to know a little bit more about the go-to-market strategy for approaching the different vineyards and winemakers, and how quickly you plan to roll out.
Right. So I think that our go-to-market strategy also kind of, or at least ours, aligns with our graduation dates as well. The group of us the three of us are all PhD students. I'm actually a rising fifth-year PhD student, so I see the light at the end of the tunnel. I should graduate in about a year. So we're going to do a year more of product development with the help of some of the academic grants that we've gotten, and do some initial testing with some winemakers that we've already spoken to in the local area. And then after that, we plan to launch our mobile service. So this will create validation within the winery field, or the wine field, that our product actually can work, while still enabling us to do some more product development and kind of fine-tune our system to meet their needs.
So are you raising capital?
Are we raising
capital currently?
We're not currently looking for investment. We're looking for academic grants. No. Well, thank you.